Why do centenarians escape cancer? People who live to be over 100 years old. As we get older, our risk of getting and dying from cancer grows year by year, but once you hit around 85, 90, your cancer risk starts to drop. That kind of makes sense. I mean, if you didn't get it by then, maybe you're never going to get it. If you live that long, maybe it's a sign there's something special about you. It seems that centenarians are endowed with a particular resistance to cancer. So what's their secret? Well, every day, 50 billion of our cells die, and every day 50 billion new ones are born. There's a balance, otherwise our body would atrophy, or shrink, or get too big and crowded. Now, sometimes we need to grow, like when we're a baby, or that growth spurt around puberty. Right? Our cells don't get larger when we grow up, they get more numerous. A child's hand may only be made up of about 50 billion cells, and may have to add a half trillion or so growing up. Once we've already grown up, we don't want a lot of extra cells hanging around. I mean, we still need our cells to grow and divide, right? Out with the old, in with the new. We just don't want to be making more cells than we're putting out to pasture. When you're a kid, extra growth is good, but when you're an adult, extra growth can mean a tumor. How do our cells know when to tip the balance in favor of more dividing and less dying, and when to come back into balance? Well, a key signal is IGF-1, a growth hormone called insulin-like growth factor number 1. Levels go up when you're a kid, so you grow, and then come back down. Should your levels stay a bit too high as an adult, though, there's this constant message to our cells. Grow, 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 divide, don't die, keep going, keep growing. And so, not surprisingly, the more IGF-1 we have in our bloodstream, the higher our risk for cancer. More IGF-1, more prostate cancer. More IGF-1, more breast cancer. Of course, it's not the original tumor that tends to kill you, it's the metastases. IGF-1 is a growth factor. It helps things grow, so it helps cancer cells break off from the main tumor, migrate into surrounding tissues, and invade the bloodstream. And, what do you think helps breast cancer get into the bone? IGF-1. And the liver, IGF-1. Lung, brain, lymph nodes, IGF-1. Helps transform normal cells into cancer cells in the first place, then helps them survive, proliferate, self-renew, grow, migrate, invade, stabilize into new tumors, and even helps hook the blood supply up to the new tumor. IGF-1 is a growth hormone that makes things grow. That's what it does. But too much growth when we're all grown up can mean cancer. What is the mechanism by which our diet can affect our levels of this cancer-promoting growth hormone IGF-1? Imagine you're a kid with some Tinker toys. Then Christmas come early, and you get one of those huge sets dumped down in front of you. All excited with this new load of building raw materials, you may really start scaling up. And basically, it's the same thing with your liver and insulin-like growth factor 1. When you dump a load of protein on your body, your liver's like, whoa, look at all this. What are we going to do with it all? We can't just waste it. We got to do something with it. Let's just start growing stuff. Add a few new additions, maybe a new wing. So your liver decides to start pumping out IGF-1 to tell all the cells in the body, it's growing time. Be fruitful and multiply. Spare no expense. Go crazy. Look how much excess protein we got to work with. The problem, of course, is that some of the new additions may be tumors. When you're a fully grown adult, cell growth is something we want to slow down, not accelerate. So one might imagine the goal would be to maintain adequate but non-excessive overall protein intake. But wait a second. Studies have found no association between total protein intake and IGF-1 levels. Doesn't that just go against everything I just said? But these studies didn't take into account animal versus plant protein. In this study of meat-eaters, vegetarians, and vegans, they found no significant difference in IGF levels between people eating lots of protein compared to people eating less protein. But before ditching the theory that excessive protein intake boosts the levels of IGF-1, they decided to break it down into animal protein versus plant protein. Higher IGF-1 levels were just associated with animal protein intake. In fact, the plant protein seemed to decrease IGF-1 levels. So no wonder there was no net effect of total protein intake. Animal protein appears to send a much different signal to our livers than most plant proteins. So even those vegans eating the same amount of protein as meat-eaters still had lower levels of the cancer-promoting hormone IGF-1. So It's apparently not about excessive protein in general, but about animal protein in particular. And I'll try to explain why tomorrow.